Hey there guys, welcome to the lab. Today we're going to take a look at this CONAR signal tracer model 230. We're going to see if we can't take her apart, see what's going on with it, and fix it up. This is something that I plan to use on the bench working on other tube amps. The story on this is my dad actually went to an estate sale and found this. Apparently a guy had a bunch of old test equipment like this, was working on ham radios. My guess is it was an estate sale, so somebody probably died, unfortunately. Uh, but the guy who was using this probably croaked a long time ago, or maybe stopped using these items a long time ago because I got a bunch of stuff and none of them work and they were all really, really nasty. So, what we're going to do is we're going to plug it in and turn it on and see if we can't get it to work. Right now, I've got it plugged into my isolation transformer, which is plugged in to my current limiting power supply. So let's go ahead and get this thing going, see what we can find out. Okay, so right away we've got what appears to be a dead short. So I'm going to go ahead and turn this thing off, and let's go ahead and pop her open and see what's going on here. Okay, let's open her up and see what's going on. For those of you who are unfamiliar with what a signal tracer is, this is a device that you can basically have the probe here. You've got your crown clamp, which is broken off here. I'm going to have to fix that. But basically, you can probe through the circuit of either a radio receiver or an audio receiver. You can see, if you have sound at a particular area, if you have signal at a particular area, you can keep on going through that signal path. And when you lose or either get signal but it sounds weird, then you can obviously specify about where your issue is. So if you notice, this thing does have a speaker on the other end, and you can see it's got a radio frequency, audio frequency switch there. Now, to be completely honest, I really don't plan to use the radio function much. It only works into the AM band, but I plan on using it on the audio frequency side just because that's mainly the bulk of the work that I do. So let's go ahead and open this thing up and let's see what's going on. Okay, so we got our speaker here, which is soldered in place, so that's going to have to hang out there for a second. Got our tubes here. I was also lucky enough to find not only the schematic for this, but also the owner's manual and even the instructions on how to build this thing. So this is a CONAR, which is part of National Radio Institute. My guess is this is sometime mid-60s when this was made. I can probably date that when we open it up, take a look at it. And this would have come in as a kit. Somebody would have got this, it would have come with a bunch of different parts, and they would have soldered it together. So I don't really see anything too obvious. One of the things that we're going to do is I'm going to break out the tube tester and we're going to see what's going on. So I was taking a look at some of the different charts in the maintenance section of this manual here for this signal tracer, and it claims to have 7 different tubes, and it talks about what voltage should be present on all these different tubes here. It claims to have 7 tubes. However, I'm only counting 1, 2, 3, 4, 5, and 6. There's nothing underneath it, so I'm not sure what I'm missing there, but we'll figure out what's going on. Maybe this is a different, an updated model. Not too sure, but we'll figure that out. Okay, after consulting the schematic here, you can count them: 1, 2, 3, 4, 5, 6, 7. 7 tubes. And that one is the one that I'm missing, which is part of the probe. So apparently there is a tube in here. And sure enough, when you pop off that cover and peel the sheath back here, there is a tube inside. There it is right there. So really, really neat. So let's break out the tube tester and let's see what these come up with. Okay, so I've got the tube tester out. This is probably one of my favorite tools in the lab here. This is the famous ICO model 666. Mark of the Beast sends bad tubes straight to hell. So taking a look here, we're going to just run through these tubes and see what's going on. Off camera, I did power it up again with the obviously through the current limiter there, and I noticed that the filament on the eye tube was lighting up, as well as some of the other tubes. But I wasn't getting any sound out of the speaker and didn't get any kind of glow out of the eye tube. So at least the filament secondary of that transformer is good. But it doesn't appear that we have any kind of B plus or no high voltage. So we could potentially be looking at a bad transformer, or maybe it could just be as simple as a bad rectifier tube. So let's go ahead and pop a few of these in there. Let's see what we find. I'm going to start off with the 6X4, which is that rectifier tube. That's going to be that guy right there. Let's go ahead and turn this thing on. Got to find it in my list here. Now I'm going to come up with a video at some point to go through and explain how to use this tester, but I'll kind of explain it a little bit as I go through the process here. So, got the 6X4 tube. Let's go ahead and get this set up here. So we have 6.3 filament voltage. We've got 0 grid. And we've got it set to 90 on the plate. And we've got our numbers here at 41121. So 41121, and then 6, and then 1 across the board. And then the V and the S are set to 2 and 1 respectively. Okay? So let's see, where's this thing fit? Okay, so I feel it getting warm in there, so it means that filament is potentially good. And again, basically how these things work is you've got your settings here. The first thing that you do is, first of all, make sure that the filament does light up, which I'm actually not too sure if this thing's working or not. But basically, then you go through and you check for leakages, any shorts within the tube, and you do that with, once you've got everything set up, you can go through the different push buttons here according to your chart, and see if anything is shorted, or in this case they're calling it leak. But basically, if something is shorted, it will peg this needle all the way over. Now, it may be hard to see, but if you take a look at the buttons that it's talking about, so 1 and 7 here for the first side of this tube. 7 is, it may be hard to see there, but it's got an underline. So the 7 is underlined. So any number that is underlined, you basically hit the heater cathode leak, because it will automatically pin that, and you will basically hold this button to make sure that it goes back to 0, indicating that there is no short there. So again, we're checking for 1 and 7, and right out of the gate, when we hit 1 here, it just immediately pushes that over. So what that's telling us there is that we have a dead short on pin 1 of this 6X4 tube, so that is definitely no good there. I'll check 7 as well, and I'm not getting anything on 7. Basically, if it passed the leakage test, then you can set it to the correct number here, which would be item number, or pin number 1, and you can pull the merit lever. But you should never actually merit the tube and see how strong it is if it fails this test here. So the first side of this tube definitely didn't pass snuff. So let's see. Let's take a, just for fun of it, let's see what the second side looks like. So these numbers are pretty much the same. You just switch the 4 and the 6 there. So that's 6, and then I believe I had this set completely wrong. Hang on. Let's try that again. 41121, 41121, and then 6, 1 across the board, and then 2, 1. Okay, let's try that again. So 1, same thing, 7, nothing. Okay. So that side is still bad. So let's switch these 6 and 4. And then on this one, we're checking 6 and 7. So 6 here, again, another dead short on 6. So this tube is completely bad. No good at all. Luckily, I think I have another one of these. Hang on a second. Okay, so I do happen to have another 6x4 tube. We're going to pop this in there. Claims to be new old stock. Let's find out. We'll pop this in there and see how it does. So again, 411216111, and then 21. Okay, looks good there. So again, we're checking for pins 1 and 7. Go ahead and pop this thing in there. Okay, so you guys may not be able to see that, but the film on this one is certainly lighting up. I can see it through there. So let's go ahead and test this. So pin 1, nothing there, indicates no leak, no short. That's good. And then on 7, this should peg the needle. And it does. That's okay because, again, it's got that underline there. We're going to press that heater cathode leak, and sure enough, it goes back to 0. Or close enough to 0. We're going to call that good. All right. Perfect. And now we're going to test this. We're actually going to merit this on pin 1. So I'm set it to pin 1, and then we pull the merit button. Looks pretty good to me. Seems pretty stout there. So that side's good. Let's check the other side. So again, that was 6 and then 4. Everything else should be the same. And then on this time, we're checking 6 and 7. So 6, nothing there, which is good. And then again, let's see, yep, 7 is going to be, going to pin that. Again, that's okay. And we're good to go. All right. And then so we test this one on 6. Looks nice and strong there. So this tube does appear to be pretty all right. So I'm going to pop this in there. We're going to see how the other tubes fare. Sorry guys, the camera died there. But I was just getting out this Magic Eye tube. This is a 6E5. Definitely one of my favorite tubes to test. Is going to be a Magic Eye tube. This one, at least on certain eye tubes, will actually light up the eye. So we'll actually get to see how strong this eye is. Really cool. Okay, so I see that, I think I see that filament heating up. Alright, let's go ahead and test it. The ones that we're looking for here is going to be, let's see, where are we? 6E5, 2, 3, 4, and 5, then we merit on 4. Now when we actually run the merit test on this, it will also not only tell us how strong the tube is, but also it's going to light up the Magic Eye there. So I'll definitely be sure to show that. 2, 3, 4, and 5. So 2, we're good. 3, we're good. 4, we are good. And then 5, we are good. And then we test this one on pin 4. Let's go ahead and try this thing out. So test very, very strong there. I'm actually gonna, maybe hard to see the eye actually lighting up here because of the big light that I've got. So let me turn that off, and maybe you guys will get to see this a little bit better. So that eye actually looks really, really strong. I'm extremely pleased with that. So looks like we've got all good tubes in here now. Let's go ahead and at least put all the tubes back in it and button it up and see what we have now. Alright guys, we're back. It's been a couple of days. But I believe where we left off was I had just gotten the tube tester out, tested all these tubes. They all tested good with the exception of this guy back here. That was our 6X4 rectifier. It's actually this one right here. Luckily I did have another one and I popped in there. It did test good. I've not turned it on since then, so let's go ahead and do that and see what we get. When I turned this on the first time when I first got it, that bulb over there lit up really, really bright, indicating either a short or it was drawing a whole bunch of current. So there's definitely something wrong there, and I believe the culprit of that was this bad rectifier tube. So again, I'm gonna pop this thing on. We're gonna see what we have. So right away, that seems to be a lot better. Our bulb right here is not flashing extremely bright. Let's give it a couple of seconds to warm up here. I can see the filaments are lighting up. It's good. And I don't know if you can see this, but that eye tube is trying to light up a little bit. Let me turn the light off here. You might be able to see that. Let's see, still no still no sound though. Actually, it's trying. So let's turn up the volume here a little bit, make sure it's set to audio frequency. Hey! Sounds like a scratchy pot, but that's okay. Not getting anything out of by touching the probe. I should be able to get something. I'm going to plug up my signal generator and let's see what we find. And normally you would have a clip on this, but again that broke off. So I've stripped the wire back and see if we can get anything out of this puppy. Okay, we got something there. That's with the volume all the way up. So, should be a little bit louder than that. I'm finding, let's see, I've got it set to just a little over 1,000 hertz frequency. So, that's that tone that you hear. So it is working. Just a little bit weak. There's a chance we could have some low B+. I don't know. Also, this light not being very bright, this magic eye here, it tested really bright, but it's not showing up really bright right here. So I'm suspecting we got some voltages that are a little bit wonky here. I was taking a look at the, wherever that chart is in here. Yeah. This chart here, taking a look at the 6E5 tube, which is V6, that's this guy. On pin number... Okay, so that beep you just heard was the beep that my garage door opener makes when my wife comes home. So I'm just going to do a quick voiceover for this part. But what I was saying when the video cut out is the target voltage, or the voltage for the target on that eye tube was about 215 volts. And so basically those eye tubes need fairly high voltage from the B+ to make the phosphors glow in those tubes. Now, on this particular amp, or this particular unit, we were getting about 85 volts. So when you're getting low B plus in an old tube unit like this, generally the first thing you want to look for is going to be the filter capacitor, which is going to be that CAN capacitor. So I actually ended up finding that was bad. You'll see here in a second, as well as there's a resistor right in there as well between those two filter capacitors. That was also pretty far out of spec. So one of those two things were keeping us from having high voltage. And here coming up in just a second is where we test those. Okay guys, so it's been several days here. Again, we suspect that this capacitor is bad, this filter can. It is an old Mallory. It's a 3030 at 350. So two different capacitors in here. I went ahead and clipped it out, did some testing on it, and sure enough it is bad. Here's its replacement. Got a 3232 at 500 volts from JJ. So we're going to go ahead and put that in there, but before I do that, I want to run you guys through the process of how I actually tested this one. I believe this is the original filter can capacitor, and you can see it over here in the shot. I've got this very cheap Chinese tester from, I think I got it from Amazon for hardly any money. Did some testing on it. It was saying that it came out, both sides came out around 47, 48 microfarads of capacitance there. It was had a pretty low ESR about, I think it was like, I'm trying to remember, it was like half an ohm or something like that. And then it was saying the voltage loss was actually fairly high, it's about 12 or 13%. And again, they were pretty much the same on both sides of this capacitor. I would love to show that to you guys again. However, the battery's dead on it, and I'm not gonna wait for it to charge. So I do have another tester here, and I tested it on both of my testers just to make sure. This other tester that I have, I'm going to show it to you here in a second, but it's actually an older one from the 50s is my best guess, and I can actually subject it to some high voltage, and we can see how it behaves at higher voltages, since this thing can only provide about 4 volts. Okay, let's go ahead and do that. Well, that's a lot better. I got a new camera, guys, and this looks a hell of a lot better. So what I've got here is, this is my other capacitor tester. This is an ICO 950B. My guess is it's mid-1950s is when it was made. I did a full restoration on this thing. It really truly is like a museum type restoration. I've put new screws on it and painted the case and all that. I actually ended up having to buy 2 of these broken, and then taking parts from 2 of those and then making a good one out of them. I was really pleased with how well this case cleaned up here. But what we're going to do is we're going to test out both of those, or test the old capacitor here in that signal tracer, and just to prove to you that it is bad. And just for reference sake, once I've proved that this one is bad, I'll plug in the new one next to it, and you can see how a good one's supposed to work. So let me turn this thing on. Now this is, one of my absolute favorite tools on the bench, just because it's period correct, it's old, but also it allows me to do, I can check for capacitance and things like that, but again, really what this allows me to do is test for leakage against high voltage. So if you notice on this left dial here, this would allow me to turn up the voltage up to about 500 volts here under an electrolytic test. That way I can see, I've seen a lot of these old machines that will have capacitors that test good on a modern tester and seem to test okay on other testers, but once you subject them to the high voltage up near their limit, or again what they're going to be seeing in their intended circuit, they actually might start leaking a lot. So this is a really good tool for that. Now you can see up here is your magic eye. So this will allow us to, again, this is kind of your only feedback as far as what's going on with this thing, and giving you all that information. So I'm going to test the capacitance first. So right there we're testing between 0.1 to 50 microfarads, and the way that this works is you move your dial here until you see that open and close. You basically just kind of try to get it to where it's at its widest point, and that is your capacitance value. Now this one, it takes some getting used to read this thing, but right there there are 3 tick marks, and this bottom one, according to the range that we're set on, is 50 microfarads. So this is almost 50 microfarads. The one right before it would be 40, so this is, I'd say, about 47 or so microfarad. So this has drifted way up in value. So we already knew that, again, from testing on the new tester, that Chinese one. But to show you really the real problem with this thing is I'm going to flip it back over to electrolytic test, and we're going to put some high voltage on this thing, and we'll see exactly what's wrong with it. So again, there are 2 capacitors in here. It's a 30 and a 30, and they're both at 350 volts. So I could run it up to 350, you know, and still consider it safe. I may actually be a little bit shy of that just because it's so old. But basically, the way this works is as I turn this knob up, the magic eye will close, and then if that capacitor is charging, it will open back up. And on this one, if I open it up just a little bit, we're at about 10 volts there. You can see that it's opening and it's charging. That's good. And if I turn it up, I've got it to about 150 volts there. And you can see that it's closed and it really doesn't want to open. It is opening a little bit. You may not even be able to see it on the camera there. But it's extremely slow. And we're only not even halfway up to its intended working voltage. And it's just really, really slowly charging. So if I crank this up even more, we'll say to about 250. At that point, it really can't, it's really not doing anything. So this is definitely leaking at, we'll say, around 250 volts. And because of that, that's probably why this thing is acting up and our signal tracer isn't doing its job. So one thing to note about this, when you have it set to electrolytic test, the range switch, and you have this voltage knob turned up, let's say if you have it at 400 volts, there is 400 volts on these plugs right there. So definitely no touchy if you've got an old unit like this and you're using it. So I've got it turned down. I'm even going to take it all the way back here. And I'll unplug that. And I'll plug this new one in here. So this new one is going to be the replacement. And this one is a 32 microfarad. I couldn't quite find a 30 and a 30. But this one will go up to 500 volts. Okay, so again, we're spec set here to 0.1 to 50 microfarads. So we're going to confirm that the capacitance is in a good range. You could say, let's say it's good about there. And this is not quite at 40. I'd say it's 30, 35, 6, 7 or so microfarads on just this one side. I'm only going to test one side just to prove kind of the proof of concept here. But again, capacitors generally will be high in value, and that's okay. That'll work just fine for what we're trying to do with it. Now, as far as the voltage test, the leakage test, again, this is a 500 volt capacitor, so I can really just crank this all the way up. And I shouldn't really have to worry about this thing harming this thing. So let's roll it all the way over to electrolytic test. And as I turn this up, you'll notice that on a newer capacitor like this, a brand new one that hasn't been, you know, it's not 30, 40 years old, if I turn it up, we'll say I've got it to about 150 there, and you can see already it starts opening up pretty quickly. And on this one, you don't want to just completely crank it immediately, but you can turn it. So this is all the way up. That's about 480 volts. And it's slow, but you can see that it is opening. That's a lot of voltage on a capacitor this size. But you can see in just a few seconds I've been talking here, it has already started to open. So that is good news. That is a working capacitor. So what I'm going to do now is I'm going to take this out, put it back in the tester. I also realized there was a resistor or two that's out of spec, so I'm going to replace those as well, and maybe then we'll have a working unit. We'll just have to see. Okay, so I have replaced the filter capacitor, that CAN capacitor in this thing, and then also, if you guys saw in the schematic that I had pulled up earlier, there was a resistor that was across those two capacitors. That was way out of spec, so I've replaced that as well. And put the tubes all back in. I'll just put it back in the case here. It's not attached. I'm going to turn it on. We're going to see if that fixed the B+ problem. This light, this magic eye, should light up really bright, and we should be able to get a lot more sound out of the signal tracer. So I've got the signal tracer plugged into my isolation transformer, which this multimeter is reading off the voltage that it's seeing. Right now we're at 121, and the isolation transformer is plugged into my current limiting power supply. Okay, so let's go ahead and turn it on. So we get a little bit of a flash out of the light bulb on the current limiter, but again, nothing too bright, so I don't have to worry about that. Just give it a few seconds for this for that eye to appear. So I can see it coming on a lot better, and I don't know if you can see that through the camera or not, but that is actually extremely bright for an old tube. When I pull that light off, you can see that that eye is really, really bright. Let's get a little bit of volume here. Okay, got some microphonics, but we are amping. That's really, really good. Now, I should be able to touch this probe and see if we get any sound. Very nice. Well, that part's working. I want to move the camera in so you guys can actually see the magic eye working as well. When it gets signal, the better the signal is, the more that eye will close. So let me move the camera and I'll show you guys. Okay, so this should be a little bit better view for you all. Now when I touch the probe here, you can see that that eye does close, and of course you can hear the frequencies that my body is picking up through that probe, through the signal tracer. So again, the idea here is that when you're probing through the audio section of a radio or just an audio amp, as you poke through there, you can actually keep the volume all the way turned down, and instead of having to hear a buzz or a tone or whatever you've got going through that amp, you can actually just watch that magic eye. And as I change the fine attenuator, if I turn it, it's kind of backwards, right? So if I set it further to the right, that decreases the attenuation, which in other words just makes it louder. As you can see, as I decrease that attenuation, that eye gets closer and closer to being closed. Now at some point, let's say if I just dime it here, and that eye closes fully, that means that it's actually blocking some of the signal. So you want to play with either the fine attenuator or the coarse attenuator to make sure that eye doesn't overclose, or you're going to be losing some frequencies. So let me plug in the signal generator, and we'll see what that sounds like. Okay, so I've got my signal generator turned on to just about 400 hertz here. I've already grounded the signal generator to the ground, which is again just I haven't replaced the wire and the clip yet, but basically to the ground lead or the case of the signal tracer. And the positive coming from the output coming from the signal generator is this clip that I've just clipped to the paper there, so it's not moving all over the place. Now, when I take the probe and touch it to that, we should be getting should hear that 400 hertz tone. Wow. Let me turn that down a little bit. So in this case, we would actually want to turn up the attenuation. That's a whole lot better. So you can see as I touch it, that eye doesn't quite close all the way. Well, that part works beautifully. Now I wonder if the radio frequency part of this thing works. Let's try that out. Okay, so let's just sweep it through the band here and see what we get. Getting a little something there. I hope I don't get a copyright thing on this, but I've got a pretty strong Mexican radio station. Now, I know that this one, so it's off alignment a little bit. I know it's off of alignment a little bit because I know that particular station is about 1080 where I'm at, and we're setting a little over 1100. So I will have to go through and align this if I want the radio portion of it to work, which I think I will go ahead and fix. I mean, the main reason I wanted this is just for audio frequency. But I do have a few radios around here that I would like working, so I think I'll use this. Let's see what else we have. Okay, guys, so I think I'm going to stop it here for the kind of the first part of the restoration for this thing. In video 2, I'm going to go through the alignment procedure to get this thing working, so it can actually pick up some more radio signals. I'll align it. I'll kind of go through the amp a little bit more and see if there's anything else I need to replace. I'll probably clean up the case a little bit. And then I guess for the finale of this project, or again at the end of video 2, I will actually pull up a non-working amp, if I can find one, and we'll actually do a little bit of troubleshooting with this. If I don't do it in video 2, then trust me, we will definitely see this thing in more videos as I use it and just working on other things. So hopefully you guys appreciated this, and yeah, thank you. Tune in for more old crap.